So now that we graphed the square root parent function, we're going to learn how to move it around, how to transform the graph of it. So here's the key ideas that we're going to use to transform something. Here's the parent function. We just graphed it, and you know what it looks like. It should be in your notes by now. You have that y equals the square root of x. So let's see what type of transformations we can do. If I add a negative, so this is going to be something like this according to what we graph, right? So if I add a negative, I'm going to have a reflection over the x-axis. That means that this is going to be reflected across from the x-axis. And I'm going to have something like this. If I stretch it, or if I have some kind of shrink, that just means that it's going to be either taller or a lot shorter. That's a pretty bad example. This would be a shrink right here. Something a lot shorter, if you will. And if I have a horizontal translation, that just means that I move the function on the around the x-axis. Notice that normally it should be centered at 0, 0. Now it's centered somewhere further on the positive side. And what the k would do is move it vertically, so I would have something like this. Instead of being centered at 0, 0, it's centered somewhere at 0, 5, if you will. So here's an example of what we can do. And the first example is, what are the graphs of y equal to square root of x minus 2 and y equals to square root of x plus 1? So here I conveniently wrote the table of the parent function. So all that means is, and I'm going to label this with blue, and I'm going to label this with red. Notice that we have, let's say that this is our parent function. There are two ways to do this, and I'm going to do them both ways. First way is to kind of go ahead and do it like we did previously. We create a table, and we graph them. So this is the parent function. This is y equals square root of x. I already know the points. This is 0, 0. This is 1, 1. This is 4, 2. And this is 9, 3. If I have a minus 2, let's take a look and see what it does. It's a horizontal shift. Sorry, it's I apologize. This minus 2, it's a vertical shift because it's outside, just like this guy right here. Right? So that means that I'm going to take every point and move it down 2 slots. So from 0, 0, I'm going to go to 0, negative 2. From 1, 1, I'm going to go to 1, negative 1. And from 4, 2, I'm going to go to 4, 0. Similarly, from 9, 3, I'm going to go to 9, 1. Notice how every point just move down 2 on the y-axis. 2 places on the y-axis. Same thing with this. If I have 0, 0, this vertical shift is going to move it up 1. So that means that I'm going to take, I think what I'm trying to say is, if you have this memorized, Or if you have these points memorized, all you gotta do is kind of move them around. For instance, you have 1, 1, so you're gonna add 1 to the y. So it's gonna be 1, 2. This one, we're gonna be affecting the y. Again, it's a horizontal stretch. It's a vertical stretch, so you're gonna have 0, 1. Again, it's a vertical stretch, so I'm gonna have 4, 3. We're going up 1. And from 9, 3, we're going to go to 9, 4. And again, we just go ahead and graph it. And we know that the parent function moved 1 up. So this one would be y equals square root of x plus 1. And here we're going to have I mean to use blue over here. Y equals square root of x minus 2. So I told you that was one way to do it. I'm going to teach you the second way to do it, which may work for some of you. My second method, it's to simply create a table. So in this method, what we did was use the parent function. We know exactly where each point was located for the parent function, and we moved everybody one spot. What I'm going to do now is work by creating tables. Let's say that I want to work on y equals square root of x minus 2. I'm going to go ahead and create a table. I know that whatever I have in here, I want that to have a perfect square root. So I can choose 0, 1, 4, and 9. So what we're going to have is when x equals 0, the square root of 0 is 0, minus 2 is negative 2. When x equals 1, square root of 1 is 1, minus 2 is negative 3. Sorry, 1 minus 2 is negative 1. Can't do math today. And we're going to continue doing these tables, and this is what we're going to obtain. So I just did the math for the rest of the table values, and I obtained the following point: 0, negative 2, which is going to be, somewhere down there. And I'm not going to graph it because I don't have enough space. I'm going to have 1, negative 1. I'm going to have 4, 0, 9, 1. So unfortunately we didn't have space to graph all of it, but you saw what I did. You know what it looks like from the other method. So let's say now that I want to do the other table. Again, I'm going to look at these guys and say, well, I want this to have a perfect square root, so I'm going to choose the same table values. 1, 4, 9. So the square root of 0 is 0 plus 1. Sorry, this is the function we're working with. Plus 1 is just 1. Square root of 1 is 1, plus 1 is 2. The square root of 4 is 2, plus 1 is 3. And this is going to give me a 4. So when I go ahead and plot it here, I just have 0, 1, 1, 2, 4, 3, and 9, 4. Notice that we get the exact same graph we did up here. So regardless of what technique you choose to work, please make sure you understand it 100%. On tomorrow's video, we'll continue working on the next transformations.